Um, we'll start reviewing today, and I will finish maybe 5 minutes before time to catch up the final exam for the lab today. So let's look at this question and tell me how you can solve this problem. What's the formula for the compound formed when an aluminum ion 3 plus combines itself with an oxide O2 minus? Well, we know that ionic compound, you have to swap not the plus, but the number here, not the charge. So let me just correct myself here. Charge, just take the number. Here will be 3, and here will be 2. So the answer is Al subscript of 2 OL3. So the answer, where is it? The answer, this is not, this is not, this is not. The answer is B. Okay, guys? The answer is B. So let's see if we are correct. I'll take my picture out here. The answer is B, correct. Okay, guys? So, next. Answer is B, correct. So, if gallium atomic number is 31 combines with selenium atomic 34, what is the most likely formula based on your knowledge of the periodic table of the element? Where is gallium? Gallium is 31 in the third group, third A or 13. So gallium is, gallium is Ga, correct, small a. And the third group means the charge of this group is 3 plus, like aluminum 3 plus. And the selenium under oxygen group, the oxygen group is selenium Se 2 minus, like the oxygen, correct? Now you swap the numbers here, just only the numbers. So the formula ionic of the compound will be Ga, the 2 underneath Ga, and the Se will take the 3 of gallium. Okay, so which one is correct? This one is not correct. This one is not correct. This one is not correct. The only correct one is this one. Correct, guys? Let's see. The answer is D, correct. So the answer is D. If you have any question, just ask me, please. So the answer is D. So at this time, and then we'll jump to another topic. So this is D. The answer is D, and let me get out of the periodic table. Yes, let's take this one here. Maybe one or two of those, and then we'll go for another topic. Correct, guys. So what is the electron configuration of the valence electrons for a ground state of germanium? Well, germanium, you have to look. Where is germanium? Germanium will come after gallium, which is Ge, correct? Ge is 32. So the Ge, cite it here, Ge has 32, the atomic number is 32, which is 32 protons, 32 electrons. So we have to accommodate to 32. So what is electron configuration of the valence electrons? The valence electrons are always found in the outermost shell or orbital, correct? In order to get the valence electrons, I need what? VEs equal number of the group, correct? Equal number of the group. Everybody agrees? This is very important information. So the group of germanium is 4, correct? Group what? Group 4. Or call it 14, group 14, which is 14 minus 10 is equal 4A. So V is how many then? V is 4. 4 electrons. So you look at the whole thing and you ask yourself, which one will provide 4? This one, correct? And that's the answer here. Are you following? That's the answer. This is 2. This is 12. This is 10, 12, 14. This is 4. And we said it's 4. So the answer is D. So let's take another one and then you tell me. This one I'm not showing you the answer up front. So here it is. So what is the ground state electron configuration for zirconium 2 plus? Zirconium 2 plus ground state. So zirconium is, first of all, always put the element here and then look at the periodic table and see where is zirconium and how many valence electrons or how many atomic, what is the atomic number of it? Somebody will tell me where is zirconium? Underneath titanium, correct? Underneath what? Titanium. This is 4B. 4 what? 4B. That's a group 4B. So zirconium has how many? 40, correct? Everybody following? So atomic number is 40. Everybody's looking at the periodic table? Yes, so that is 40. Okay, so now you'll ask yourself, okay, well, I have here zirconium 2 plus. Means if zirconium here had lost how many? Because this is positive, I have to subtract. 40 minus 2, this is 38. So zirconium now 2 plus will have 38 electrons, correct? Now, I have to count for all those here. So krypton is 36. Krypton, Kr, is 36. So 36 and 2, that's 38. No. 36 and 4, 32. That's no. And this is 36 and 2, 38. This is correct. So let's count this. 36 and 2. Is it correct? Where's zirconium? Zirconium is 5s is missing because it's in the what they call it, it has to have a d orbital. 5s, that's for the group A's. For the group A's has only s, but it has to have d. In order transition elements, they have to have d. So, and this is here 36 and 4. This is 40 here. This is correct, but this is 38. However, it has the problem with 5s2. That's not correct. It has to be a d there. So this one here sounds very good, but it has more. 36 plus 2 plus 4. So this is 42. So the only left is B. The only left is B, correct? So let's do another one. Let's do another one. Let's see if you can follow me here with this. Okay. Okay, so let's see if we can get which atom has the largest atomic radius? Potassium, iodine, rubidium, or tin? You look at their position in the periodic table, correct? So right? In each of those, potassium group 1, G and P. Group 1, period number 4. G, that's iodine. G, the group is 7, 7A, 7. This is 7A here, 1A, or 17, or 17. And the period, iodine period, where 1, 2, 3, 4, 5, correct? 5, iodine 5. Rubidium, where is rubidium? Rubidium is 4, correct? 1, 2, 3, 4, 5, 5 rubidium. Rubidium is, period is 5, group 1. Tin is, where is tin? Tin group 4, group 4, 4A, and period is tin is period what? 5. So guys, if you remember the atomic radius will go from here, from the top to bottom is increase, correct? And from left within the group, this is within the group, this is within the period. From left to right, correct? The atomic radius increases. This one here will, from left to right, will decrease. So now, knowing this, if you go further to the 5th period, so those will decrease. What is the largest? The question is the largest. So 5 and 5, those will be less, correct? Then you have group 4A, 7A, and 1A, correct? So, and here's 5, 2, correct? 5, 2. 5, 2. Now, potassium is 4. However, within the group, you will see which one, potassium or iodine. So which one? Potassium or iodine? Which one? The radius. Within the group, if you look at the group, rubidium is larger than potassium, than sodium, than lithium. But if you go for the iodine from left to right will decrease. So rubidium is rubidium here? Rubidium is higher than potassium and then iodine, correct? Although this is number 5. And tin is the other side, will decrease. So the answer is which one? What's your answer here? Look at the rubidium. Rubidium from left to the right, correct? You will see tin and the iodine in the same group. Potassium is away. Potassium, rubidium within the group, rubidium is larger than potassium. But within the period, if you go to the right, it's decreased. So iodine is the least one, followed by tin, and rubidium is the largest one. So your tip will be rubidium has the largest one. So let's see if we have correct. Answer is correct. Rubidium is the correct one. Just I used the fact that the periodic table from top to the bottom increase, from the period from left to right decrease. That's the fact I used. Okay, guys? So the answer is rubidium is more, has largest radius. So you saw the answer of this, but I want you to see. Arrange elements: lithium, neon, sodium, argon. Which one will give you the good one than all the other ones? Again, you use the rule is from top to the bottom is, this is top, this is bottom here. This is the group within the group. That's an increase. That's atomic radius, AR. But from left to right, period here, you have a decrease. Okay, guys, I want you to memorize this because that will help you in arranging all those or answering all those type of questions. Correct? Just look at the whole thing and see which one. So where is sodium? Sodium is in the third, and you have to locate each one of those elements to see where they are at. So you have sodium in the third period, lithium in the second period. First, all of them are first. Argon is in the 8th group and third period. And neon is in the 8th group and second period. So, which one? Well, it turns out to be, if you go from left to the right, that's an increase, correct? A decrease. If you go from the top to the bottom. So, comparing sodium with lithium, sodium is bigger. Sodium is an increasing of the first. Sorry about this. Let's speak not atomic radius. Let's speak about what? Ionization energy. Well, the ionization energy is totally different. It's the opposite. So this one here, the ionization energy here is opposite top to the bottom, opposite to the radius. So this one here will top to the bottom will decrease, and here will increase. So the ionization energy of sodium compared with lithium, lithium has larger atomic radius, so less ionization energy. So sodium is the least one. Then you go from the left to the right, the ionization energy, the opposite of atomic radius, will increase. So the argon is greater than lithium. So this one here is the most richest one. And neon, correct? Neon is the top. So because if you go from top to the bottom, decrease ionization energy. So if you go up, so you will see that those are more, lithium is more than sodium, and neon is more than argon, ionization energy. So this is the opposite. So here, make a note for yourself, opposite of atomic radius. Okay, guys, so I wanted to see if we have another type of questions, which is stoichiometry calculations. Let me just go here. Do you know how to solve those problems? Guys, you know how to do it? Manganese, wanna try it? Oops, give me the answer, but I want you not to look at the answers. So, manganese, ask yourself, how many electrons does manganese have? 25, correct? 25 electrons. Atomic number is 25. So, you start 1s2, 2s2, 2p6, 3s2. Where is it? What period? Manganese in the fourth, correct? So we have to have valence electron in the fourth period. So 3s2, 3p6. Now calculate 25. This is until here is 10 valence electron. Until here is 8. Then 3p will come then the 4d, correct? And then the 3, not the 4D, 3D, sorry. Let me just, the 3D, correct? And I have 8 here, and then here I have, not the 3D, sorry, not the 3D. After the 3P, 6 will come the 4S2, and the 3D will come whatever left over. This is 6, this is 10, this is 2, this is 20, and how much is here? Will be 20. How much left? Is 5 to make it 25. So the valence electrons 4s2, 3d5. Okay, and the whole thing is, and you can compare all your data if they are the same or not the same. So which one is the correct one? So look at this here and see which one is the correct one. 10. Is it in the fourth? Manganese in the fourth. So which one is correct, guys? Which one? Which one is correct? We have here. This one's correct because it has 3d5 for S2. Yeah, this one's correct. Okay, guys. So that's what you have to memorize. Those at least up to the fourth period. You have to know what the electron configuration. Maybe let's take another one. Let's take another one. Let's take another one. The answer is D. That will not come, but at least you know what the maximum number of electrons that can occupy an orbital labeled dxy. Well, the dxy, if you look, how much will be, you think? That will not come because d orbital has 5. D orbital has 5. Let me. Where is this one? Okay, guys. So let me look at this. The d orbital made of 5. 1, 2, 3, 4, 5. This is dz squared. This is dxy minus, x squared. This is dx y, dx z, dy z. Now, if you look, maximum of each of those will be filled with 2 electrons, correct? So up, one down, so up, up, and then down, 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 down. The d orbital in total will have, will have 10, maximum of 10. That's max. Now the dxy will have 2. Each of those orbitals will have 2. Correct, guys? So the answer should be B. But the total in total will be 10. So let's see if the answer is correct. The answer is correct. The answer is correct. 2. Each one of those suborbitals will have 2 maximum. Those are 5 suborbitals maximum of 2. That will be total 10. So let's take another one. I need to see what the smallest. I need to get out of this quickly here. Yes. Now let's go for nuclear equation, nuclear. What will be your answer here? What will be this? This one here, what will be? Somebody will help me? Answer is B. What's missing particle? So how you solve it? How many is here? 2. Okay. So that's your X. I don't know what the element is. So what will be here then? 26 and 23. How much is there? 4, correct? 4. Am I correct? How about the bottom? 90 minus 88 is what? 2. I go by the atomic number 2. Atomic number 2 is helium. So this will be helium. Atomic number is 2. Atomic mass or mass number is 4. So the answer is B. Correct? So that's we have to practice more. Let's see another one. Answer is B. So cobalt 60 undergoes beta decay. Beta decay. So first of all, we have to visualize what beta decay is. So cobalt 60. 60 means that's the atomic mass. That's the way we write the isotope. Isotope dash or hyphen, and then we write the top is atomic mass. The atomic number is not changing. Atomic mass change because the neutron is changing in numbers. So we go and look at cobalt. Cobalt is 27, correct? That's not changing. That's fixed. This one is fixed. 27 is fixed. This one is not fixed. Because it's the isotope, you can have, but we are looking just at 60, but it can be 61, can't be 59, and so on. Everybody's following? So 60 and 27, and it goes beta. Beta is electron minus 1 at the bottom and 0 at the top. Or you can write it beta, whether you write it E electron or you write beta. Either or means they are the same thing. I like writing E because that's electron from the nucleus. So, but this here in the problem said beta. Minus 1. So what will be the element here I'm looking for? Come on, guys. What will be that in the atomic number? This is the total is 27, and here is minus 1. How much? No, I need the number first. Then we'll go to how much? No. Come on, guys. I know it's Monday. It is Monday. This is 26? 28, yes. I know it's Monday. But we need those who are with me in the lab. Today is the final lab, so we need your attention and your complete concentration. So how many is here? 28, not 26. 28. You add those up here, what will be equal to what? 27, correct. How about the top? The top is 60, because this is 0 here. Add those up, it has to equal to this. So you have the element is 28 atomic number, and the atomic mass is 60. 28 is nickel. Perfect. Perfect. Nickel. So which one is out of this equation, 4 equations, is the correct one? So not iron, not manganese, not iron, is nickel, correct? Let's see here. Oh, the answer is already half of it is John. So, well, that's cheating. That's not fair. That's not fair. That's not fair. So you see the answer, tell me the answer up front, correct? Well, I'm not saying anything. So here it is. Answer is B, correct. So now here you tell me what's the answer. I'll give you a couple, maybe 1 minute. 1 minute for this. So what's the answer here? What's the answer? It's here the decay of magnesium to give you sodium and gamma. Gamma 0, 0. This is gamma here, guys. Whoops. I cheated myself. So this is gamma here. Double M, correct? I think double M. Just leave it as is. So how much is left there? 23, correct? The sum is 23. Here is 23. So then here in the top will be what? The element is x0, correct? 23 plus 0 plus 0, 23. So 23 is okay. Here I have 12. Here is 11. Correct, guys? And here is 0. So the other one is missing what? 1. What is this? Is 1 here, positive. Now, what we call this? The opposite of beta is, oh, you are letting me down. Positron, correct? This here, this is beta, correct? So this is beta here. But the opposite of beta is positron. Make sense? What's the answer here? Did we cheat it on that? No, not yet. What the answer is? B. We did cheat on that. So, okay, that's not good. But it's okay. It's Monday. So let's take one out. Let's not cheat this time. So now we'll not cheat this time. So what is the missing product of this? That will come a couple of those questions of the nuclear chemistry, balancing nuclear equation. And that's in the lecture, not in the lab. Not in the lab, that's in the lecture. The lecture is exam is Wednesday. When? Wednesday. The same thing we start. The same room, correct? The same room, what? The same room and the same time, 8:30 we start the exam. Correct, guys? So we'll be ready with it. So what will be this here x? Here is 23, correct? The total. And the top is 23, so the x will be 0 on the top, correct? How about the bottom? The bottom is 15, but here we have 16. So what will be there? What will be there here? Here is 16, but there is 15. So what will be? Negative what? Negative 1. That will be what? Correct. That will be E0 minus 1 or beta 0 minus 1. That's a beta radiation. So where is the answer here? The answer is A. Did you cheat it? Oh my goodness, that's a big time cheating. You did try to tell me? Well, that's way too late. That's way too late. Well, nice try though. That's a big cheat because this is obvious, correct? But at least I did not even see it. I did not even look. Well, it's very hard to control. Anyway, it's Monday. Well, how about that? I'm not doing anything. I'm not writing anything. So, oh, that's another cheat here. Yeah. What is this? I'm trying to hide the A's, then the D came out. Well, let's do it again. It looks like I have a bad day today. So, bad day today. So, how we solve this one here? 27. We'll solve it together to make sure that we have the right and the correct answer. 27, correct? And here's 4. How many the sum of this? 31. And here how many? 30. So then my x here will have 1, correct? 1, because 1 and 30 here, 31. Okay. Then the total here, I have how many? 15, correct? Then I have here 15. This one will be what? 0. What is this? Yeah, but what we call it? This one, we cheated on the answer, but we have to know how we call this. This one is what? You are now letting, we can't cheat. We can't cheat this time. That's a neutron. has a mass but has no charge, has no atomic number. So the answer is D, because we cheated on that already. So we know that's the answer is D. Okay. What's that? It's Monday, correct? Yes. You accept the fact it's Monday. Yes. Thank you. It's very obvious. You can see it. I can borrow you my glasses, reading glasses. Okay. If somebody needs reading glasses, I have one. So just let me know. Just let me know, guys. Don't be shy. So let's do one here. One more. So when CM, where you can find CM? Where you can find CM? Correct. Well, what's the name of that person? I'm not saying that person. I'm not specifying. Male or female? Female, correct. And where? Madame or Miss Curie. Yes. She is the one who really discovered the isotope and the beginning of the nuclear chemistry, correct? And unfortunately, her husband and she both of them were not really taking care of the safety issue. So they worked on themselves, like alchemy people. So her husband, I think, lost hand and eye, and I don't know. But yeah, those isotopes are very dangerous. If you work with them without safety, you might just get those cancers, and that's really progressing cancer, not slow tumors or something. They are very progressing tumors. So yeah, Madame Curie, yes. Curie, and then take the last alphabet from the last name, i.e., then you say the Curium, Einsteinium, correct? Rutherfordium, Rutherfordium. And you see a lot of Faradayum. So IUM at the end. So most to honor those scientists who had worked in that area, correct? So now, curium captures an alpha particle. It produces a neutron, and which isotope? So you have, it says here, we translating the whole thing here. So CM 242. This is 96, atomic number 96, atomic mass 242. Captures an alpha particle. Captures mean take in. Alpha is a helium, correct? 4, and atomic number is 2. Atomic mass is 4, atomic number 4. To produce neutron, we saw that atomic mass is 1, atomic number is 0. Plus X. X will be what? This one is very good. We can't cheat this one. X, excellent. I'm very happy with that. So we can't cheat on that. So we have to get the answer. So what is the X atomic mass? 424 plus 4, 446, correct? And here you have 1. So 440 what? In the top what? Correct? Don't be shy. 245. How about the bottom? The bottom is 98. Look at the periodic table. Which is 98? Which is 98? Californium. That was found in the state of California. So Californium. And the BK in the lab, Special Federal Lab, Berkeley Federal Lab, Berkeleyum. So wherever the city or the lab or to honor the scientists, you will see those lanthanide, actinide named too. So that will be X is 98. So 98, we said is californium, CF, correct? CF. 245, 90, sorry, the F has to be in the top part of the CF here, and this is 98. So which one we have? B, everybody likes B? Okay, let's see if we have correct. Can you see it, Ms. Carter? Thank you very much. Just checking on you. Just checking on you. Okay, so take this one out. Take this one out. Okay, let's take it out. So here it is. It's B. That's correct. Now we'll do this and then we'll go for another topic. So what is the product when plutonium, okay, 218 atomic mass, 84 atomic number, undergoes positron emission? So I give you 1 minute to do and tell me what the answer is. The answer is already, you know the answers. Maybe cover it, but it's too late is that, so everybody knows the answer. It's too late for that. I know you are cheating the answer. It's okay, but at least we have to do it together, okay? So let's do it together and verify the cheated answer there. So we have plutonium 222, that's the atomic mass or mass number. Then 86 atomic number, okay, 86. Positron emission or decay, positron we said E, correct? No mass, but positive, that's opposite of beta, positive plus 1, plus X. So what atomic mass will be in the top? What will be? This is 0 here. And here 222. So here will be 222. How about the bottom? 80 what? 85. Because 85 plus 1 make 86. So 85. Let's look, where is 85? 85, guys. 85, where is it? What's the, you can't pronounce that? Astatine. Yeah, 80, 85 at the bottom, atomic number, and 222 atomic mass, correct? So, where is this? We cheated on that answer, I think. No? Undergoes positron emission. Did I do this one correct? No, we did not. I'm sorry. This is my bad. This is I looked at this. That's 218. Yeah, I'm sorry. Thank you. It's Monday for me too. 218. And this one will be in the top will be what? 218. So this is first 218. And this at the bottom is 84, correct? Not 86. I don't know where I got the 86 here. But it's Monday. So it is 84. So this one will be, guys, how much is it? No, will be 80 what? 83. 83 will be then. 83 will be. 83 is bismuth. Bismuth. Yeah. Bi, 8218 and 83. Correct? So we have the answer already. And the answer is D. The answer is D. So it's already pretty cheated answer. So, but anyway, so let's get this one out. And let's get new ones, different type of questions. We know now all this naming compound. That's a good one. So let's start this. We have 4 of those. Which compound is named correctly? You have 4 compounds. Which one? Oh, the answer is here. I can't help it here. I can't help it. So which one is correct? So let's name the first one. Let's name the first one. The first one is not correct. So the first one is not correct. What's the correct one? A carbonate is 3 minus. And this iron here has to be 2 plus. Correct? So the name of this will be iron 2 carbonate. So it's missing what? Missing the number 2. So this is not correct. How about this one here? Strontium is, the 2 is came from strontium 2 plus. And the nitrate is 3 negative. I mean, 1 negative, but 2 of them here. 2 of them, correct? 2 of them. So this one will be what? Strontium, correct? As they say here. Strontium. Again, it's 2 is missing. The Roman 2, and then this is nitrate. So this one is not correct. So the Roman number is missing. How about this one here? Potassium sulfide, K2SO4, that's potassium sulfate, ATE at the end. Less oxygen will be potassium sulfite, ITE at the end. So the answer is correct. This one is the named correctly. How about this one here? This one is missing. The 3 here is coming from what? From the cobalt, correct? So this one will be cobalt, not 2. 2 is not correct. Cobalt 3. Cobalt 3, because the 3 is coming from the cobalt and the 2 from the sulfate. So cobalt 3 sulfate, that's not correct. So the 3 ones, they have problems with the Roman number. And the only one correct without a Roman number is potassium sulfide, ITE, because one less oxygen, correct? So then if you go further, we did not cover this one here, but you can have SO2, for example, it's not there. But if you have something like this, will be what? Less 1 oxygen will be potassium. What will be the name, you think? Hypo sulfide, ITE at the end. But you have the hypo because 1 oxygen less from the 3 is 2. Okay, don't worry about this. So let's take this one out, and the answer is correct. The answer is B. So let's take this one here. The answer is B. What is the name of Ti3PO4? What's the name of this? Which one? You have the answer already. You saw the answer. It's a bad day today. The answer is coming. That's like they want to reveal themselves. They don't want to hide. What's that? Now look at that. If guys look at this. Let me just take this one apart. Let's take this one apart. When I have 4 here, correct? The 4 for the titanium. Remember the swapping? And the phosphate, the 3 here from the phosphate. So this one here is 3 minus, negative. So it will be titanium what? 4 phosphate. Titanium, this is number 4 phosphate. So the 3 is not correct. Titanium tetraphosphate is not correct. Titanium phosphate is not correct. The answer is C. You have it correct? Yes, the answer is C. Well, I can't really predict where there will be the answer is, but let's try to hide it as much as possible. Well, it's revealed itself. So let's see. Yes, that's hidden. No, reveal itself again. What's the name of this? In the name arsenic trichloride. The prefix tri specify what? So we have arsenic. Oops, sorry. Arsenic AS and trichloride. This is arsenic trichloride, correct? So the tri prefix what? Related to what? To arsenic or to the chlorine atom? To the what? To the chlorine atom, correct? Now, what will be this one here? Arsenic is 5. It has 5 electrons, so you have to use that structure. Arsenic is the 5th group, so you have AS, and then you have chlorine here, and chlorine is here. So this is AX3E1. Or I put sometimes B here, so you can put B, whatever. So like AB3E1. So what will be the first I want to see the geometry. What's the geometry of this? Trigonal pyramidal, correct? Trigonal pyramidal, AX3E1. You have to memorize this table I gave you, correct? That's the molecular geometry or shape. Okay, guys. Now, what is the tri? Now we didn't answer this question. The tri prefix specify arsenic has an oxidation of 3 minus, correct? If I take this one here aside, the oxidation number of arsenic, I know the chlorine is always -1. The arsenic, and 3 of those here, correct? 3 of those. Arsenic will have to be 3 plus, correct? Arsenic, that's oxidation number, the charge, because it's a neutral compound. So, 3 plus. The geometry of the molecular is trigonal pyramidal. Arsenic is covalently bonded to 3 chlorine atoms. Okay? The arsenic 3 is ionically bonded to 3 chloride ions. So which one is correct? Which one's correct? Which one's correct? Which one? The tri. What is the tri? I mean, the shape is correct, but this has nothing to do with the 3. Which one? That's not ionic compound. This is covalent. Okay? Arsenic has oxidation number of 3. Correct or not correct? Look at this. I put it 3 plus. Which one? A? You did not cheat this time? Okay. So, I gave you one is not correct. One is the tri has nothing to do with the geometry. That's not. The answer is correct, the shape, but that's not the shape, but I want you to shape. Arsenic is covalently bonded to 3 chlorine atoms. Correct? And arsenic has an oxidation number of +3. Which one? This or this? Come on, guys. You go A, and how many for C? C? C and A. How about the rest of the class? The rest of class. Well, the oxidation number of chlorine, the arsenic, is correct 3. But does it say tri, means prefix tri? This is correct if it is, but the problem is with tri. The problem is with the tri. Tri means what? Arsenic is connected to 3 chlorine atoms covalently. So what's left is C. Correct. C. Now that's correct, but that has nothing to do with the word tri. The word tri is here. That's the tri. But all those statements, all the 3 ones, except for this, that's not ionic. So this is a correct statement. This is a correct statement. This is correct regarding the tri. That's a good question. So it's not tricky, but a good one. So here it is. It is recorded, yeah. Now, what is the correct answer for this? Have the answer? No, that's bad. Well, I have no idea how I get you to cheat the answer, but that will be not in the final exam. You cannot cheat on that, believe it or not. So, well, you have the answer here. It's already circled. So, what is the name of this? What's the name of this? 2 nitrogen will be dinitrogen, 5 oxygen, not penta, and then pause. No, dinitrogen pentoxide. Quickly. So don't pause for that. So the one alphabet will be out. So which will be dinitrogen pentoxide. Okay, D. The answer is D. Okay, so let's see. Yes. Roman numbers for ionic compounds. Yeah, for covalent, no metals there. There is no Roman number. Yeah, just take the Greek number, tetra, di, tri, whatever. Yeah. Okay, so here we don't have the answer. So what is the formula of sulfur trioxide? Sulfur trioxide. Sulfur trioxide. Come on, guys. The answer is B, correct? Yeah. It's very easy. How about this? Sulfur what? Dioxide. Sulfur trioxide. This is sulfite ion. Sulfite, I-T-E, ion. And this is sulfate, A-T, ion. Correct answer is B. This time you couldn't see the answer. That's good. That's very good. But it's easy question though. So, correct. What is statement best describe ionic bonding of lithium and fluoride? Let's put, so lithium is the first group, correct, +1. And the fluoride is 7 -1, correct? So positive and negative charge for ions cancels out. Lithium atom shares. There is ionic compound, so you can eliminate this. That's not true. There's no sharing. The lithium will give its valence electron to the fluorine. Electron transfer from lithium to a fluorine atom. That's correct. Okay, guys. And an electrostatic attraction exists between lithium ions. That's not correct. That's dipole. That's not correct. So this is not correct. This is not correct. Now, you have positive and negative charges in lithium and fluoride cancel themselves out. This one here can be correct, and this one can be correct. So which one? Which one? Which one? Which one? Let's describe ionic bonding in lithium fluoride. This unfortunately is not correct way that, because A and C are close to each other, correct? That's a transfer of electron from lithium atom to to the fluorine atom. So lithium will be positive and fluorine will be negative, so the charge of cancels out. Now I see the answer is D. The answer is not correct this time. The electrostatic attraction is the dispersion forces. And this is dipole, not this. Dipole. Now we found an error inside. Dipole attraction. Not electrostatic. But anyway, it can happen. So, but that's unfortunate way of question, because A and C almost close to the correct answer. But anyway, let's leave this one here. Let's take another one. So it gives you the whole idea. But let me. Here it is. How many valence electrons are in carbonate ion? How many total? How many valence electrons in the carbonate ion? See, the problem is it did not ask you for whole total. The question itself is not correct. The question itself is not correct. Those not valence electrons. Valence electrons are found in the last outer shell. It has to be not valence, but it has to be total. So we'll switch to total, because valence electrons are just ones are found in the last outermost and ever last orbital or shell. So how many? Carbon is what in the fourth group? Valence. How much is it? Carbon is in the fourth group. How many atomic number? Is 6, correct? Oxygen multiplied by 3. 3 multiplied by oxygen, how much? Atomic number is 8. 24, correct? Now we have 2 negative charge. 2 negative. Negative charge, we have to what? Subtract or add? We have to add. 2 negative charges, add plus 2. So total will be how much? 6 plus 24, that's 30. The answer is 32. The answer is 32. And they say the answer is 24. Well, this guys, that's a mistake here. 3 multiplied by 8, how much? 24, correct? Yeah, that. And how many do we have this? 6. What's that? How many valence electrons are in the carbonate ion? No, that's valence electrons are in carbonate ion. So well, if you look at the carbonate ion, they have to tell you both. So you have, guys, here, valence electron of carbon is group number 4 is 4, correct? And oxygen is group number what, 6? Group 6 is 6. So the answer is, if you look, but you have 3 of them, correct? 3 of the 6. So 18 plus 4, how much is it? If you want to see all this one here. So, and then you have to add, they added, I know what they did. They added, this is 22, and then they add the 2 negative. Well, that's not correct. So the answer is 24 is not correct. So 3, 6, 18. The answer is if they look at the both, and they added the negative charges to the valence electron. Maybe one more, and then I will one more, and then that's it, because I want to catch up with the class. One more. What will be the molecular shape of carbonate? You saw that, correct? That's, let me take another one. Yes, so tell me what's the answer here. What is the Lewis structure for BF3? So the phosphorus will have, so here is missing what? Missing 2, because that's 5, so that's not correct. Here is missing 2, that's not correct. Here is missing, but it has more. That's not correct. The only thing is correct is this. Correct, guys? So I'll stop here, and for the final exam in the lecture, bring Scott, not Scott, bring Red Scott on your ID, GSU ID. I'm not checking on you, but I will rather you have to write your ID inside the Red Scantron. And come on time, because yes, the whole exam is really time. It's all about time. It's not really difficult. It's all about time. And do not leave anything blank. If you are running out of time, don't start laughing at me. Just do mini more. Then pick up what? One alphabet. Say C. Mr. Carter says C. Then all whatever, just C until the end. Do not leave anything blank. Those are 60 questions, 1 hour. Yes, each question, I think it's 60 questions, 1 hour, yeah. And each question is 1 minute. So now, the extra credit is due to tonight. But I'll give you until tonight. Finish them, please, the extra credit for the lecture. The homework is tonight, too. It's being graded, yeah.